So we have seen that a very basic idea of writing a program. By the way, I have already told you that I have to include these header files. Now, how we can include this? We generally write the code something like you already know. I maybe still I'm telling you, that is include within angular bracket std, sorry, io dot h, something like this, where above this main part over here, right? And depends on different header files, you have to include many more. I mean, maybe I'll have to include conio.h, something like this. Maybe another include some another something another .h, and many more. Depends on the complexity of the problem, you can do this. By the way, so what we have seen ultimately, what how we can, I mean, take a gist of what we have discussed. We can say that if I consider each and every line of the program as a point, for example, this is line number 1, this is line number 2, this is line number 3, this is line number 4, this is line number 5, and this is line number 6. So if we consider each and every line considered as a point and a node, for example, something like this. Suppose this is a node representing line number 1. This is another node representing line number 2. This is another node representing line number 3. In this way, something like this. Suppose that I have only 4 lines. Okay, I have only 4 lines in my program. I'm not got my point. So, and if I want to connect them with an arrow representing the order of execution of those lines, I can say that this line 1 will be executed first, then line 2, then line 3, and then line 4, right? So this is what you can say, this type of, if the graph is something like this, then your uh, the execution of the lines of your program, I can say that a sequential execution, right? What does it mean? Means one by one, it follows a sequence, some a sequence, then line number 1, then 2, then 3, then 4. In this way it executes, and it is very linear, right? But actually, if you just come out from these very simple statements, if you want to go for little bit complex statements, you will see that every time the statements are not so linear. It may happen that you need to decide that among, there must have some situation, depends on that you have to decide in which path you should follow. What I mean to say is that if I ask you that uh, just write a program that a number will be given, and the program will convey that number is positive or the number is negative. As simple as that. A very simple program. You know this. So what will be the corresponding program over there? That if I write a very simple pseudo code, just I will declare a variable int, say a. I mean, let's take another color. Sorry. Say the program will be something like, say, int a, then scan. I'm not actually following the syntax of C program. I'm just writing a pseudo code. That's why I've written scan A. Means the data will be scanned, and then we have to decide that whether this is greater than 0 or lesser than 0. Right. And how we can do this? You already know that we can use the if statement. That if a is greater than 0, then I must say it's positive, print positive, else print negative. Right. Now, if you just numbering these lines in the same way, this is line number 1, this is line number 2, this is line number 3. I'll not take bracket as a line. This is line number 4, this is line number 5. The problem is that up to line number 3 the execution is linear. Line number 1, then 2, then 3. But after 3, either line 4 will be executed or line 5. It's not possible that both lines will be executed or none of them. Either of these will be executed. So if you just map the situation, this particular point representing line 1, this point is representing line 2, this point is representing line 3, and then I have two choices. Either I have to go for line 4 or I have to go for line 5. So if you just do the mapping, the arrow will be something like this: line 1 to line 2, line 2 to line 3, and then you have to decide. There is a bifurcation from this point. So this is because of the condition which was absent in this previous case, right? And as soon as, just assume that you have started journey from this point, and over here you have to decide which path you should follow. Maybe you define, you go in this left path, so you follow this one, you came in this point, and after this line 4, maybe I need many more lines. I have many more path over in this side. It may happen. And how we can do this? Through this if else statement. You already have this idea. But if I tell you another different type of situation, that is, suppose I tell you that you do one thing, you write your name 5 times. How you can do this? Say, you can say that, okay, I will write something like, for example, I will write print name. So for example, write bit 5 times. So what you will do? So you will write print f, actually, I'm sorry, print f bit, then again print f bit, then again print f bit, in this way many times. And if you just think that if you want to just reflect the situation in the same way as we have defined over here, I'll have many lines over here. Each and every line is representing a printf statement, and they will be executed one by one. But what is the difference between these two? Difference between previous two and this statement? The difference is that in first two cases, this is case number 1, this is case number 2, this is case number 3, if I consider, in the first two cases, each and every lines are different statements or have their different job. One line is scanning data, one is printing, one is some adding or doing something else. But in case 3, all the points are representing same job, printf bit, that's all. Second point is that writing in this way is not at all feasible. The reason is that I told you that you write a program to say to print bit 5 times. So you can easily write 5 printf statements. That is not an issue. But if I tell you to write bit 500 times, then how you can do this? If you will write 500 printf statement in your program, which is going to make the program very inefficient, first of all, and very very poor programming from the readability point of view. Just 500 lines present in a program be written printed bit. Just see, just imagine what will happen. So obviously, writing printf statements in this way is not a solution when you have to do the same job. So what we can do? It is better if I have some way by which we can use only one statement and it executes those 500 times. I will not write printf statement 500 times. I will write printf statement only one time, but I will re-execute it 500 times. If I have a logic something like that, then the programming will be much more efficient. That is, from this point actually it came the concept of what generally we say the concept of loop. Okay, so let's see how the loop stands for, how the loop actually works. We will first try to discuss over here. Suppose that, as I told you, that I have to write printf statement say 5 times or 10 times. Okay, if I tell you to do this, not print, for example, if I ask you to say your name 5 times, just dive in your mind and very slowly try to realize that what basically you will do. As soon as you start telling your name, you start one more thing also. That is, you start counting that how many times you have already told your name and how many times you left. For example, if I tell you that write your name 5 times, when you will tell your name, you count it once you have done this. Again you will tell your name and twice. Again you will tell you thrice. Something like this. And when you will realize that I instructed you to tell your name n times and that n times you have already told, you will stop. So it's not about printing something or telling a name. It's about counting how many times you are doing also. So there is a counter in your mind which is basically doing this job. I already told you in my first class that always remember one thing, that when you will write a program, always think in the way like, always remember one thing, that human being has invented computer. Computer has not invented us. That means the way we think, the computer also think in the same way. What is our job as a programmer? Our job is to just express that thinking step by step in a form of instruction in a program. As simple as that. But before that, you must realize what are the things that you need. For example, as I told you that you need a counter. When you start saying your name, you obviously count how many times you have told. That means you have a counter in your mind, in your brain. So if you want to do the same thing in a computer needs also a counter. The program also need a counter that counts how many times the bit has been printed on the screen. right? So that means I can simply say that, say, initialize a variable, some variable with some initial value, right? For example, if I say uh, that means initial the one of the point is initialize a counter. Counter means actually a variable which counts, as simple as that. Okay, a variable which counts. Then an corresponding uh, instruction can be something like, for example, say int I equal to 0, right? After doing this, what basically you can do, you can say that, okay, when you are saying your name, you are not only saying, you are also counting and you are also checking whether you have completed the number of times that you should do or not, right? But what about for the first time? For the first time, without telling anything, you are also checking. If I say that tell your name 5 times, before you tell your name first time, you are actually setting your counter value by 0 and checking. I mean, for example, 5 times, that means whether 0 is lesser than 5 or not. If since 0 is lesser than 5, that's why you are telling your name. And as soon as you are telling your name, you are incrementing that counter from 0 to 1. And before telling your name again you are checking the present, the new counter value is lesser than the maximum limit or not. If it is lesser than, then only you are telling your name. So it happens in this way. That means somehow after initializing this, you have a checking that whether I is lesser than n or not. I'm assuming that n is already defined. For example, suppose you can define over here also int n equal to, say, 5. You are checking whether n is equal to I is lesser than n or not, or lesser than equal to, whatever you can say. If it is lesser than n, then you are printing that particular statement what was said, that is print bit. I'm not taking exact syntax of the language. Okay, I'm sorry, just updated. And after this, a very important thing that is left, you are incrementing your counter. So you are incrementing your counter only once, something like this. And after this, what you are doing, you are actually checking in this one again. You are not coming back, you are not relationalizing this I and n again. You are not doing this. After incrementing this, you are again rechecking whether you have crossed your limit or not. If you have not crossed, then you are doing it again, and it goes on. So if I just make them, if I just want to connect that particular this situation, how I can say that I have a, this is a node, this is another node, this is the condition, that's why we write in this way. I have another node over here and another node over here. So basically after doing this, what will happen? It will come here. Then from, if it is true, there is two way. Either you will go, if I is lesser than n, yes, true. If it is false, then it will go to this part where I have something, you can say end of that total execution. Anyway, so if it is true, then it will print and then it will increase this counter, and then what you are doing, you are going back to this checking again, you are not reinitializing this INN. So that means if I just draw the arrow, it will be somewhere something like this. So you see, we have a very interesting thing over here. If you just try to map the situation, if you just try to map with points, suppose these are representing some point, that means this is representing okay, not one, let's write suppose this is line number 1, this is node number 1, this is node number 2, this is node number 3, this is node number 4, and say this is node number 5. Okay, if you just do this, node number 1, node number 2, node number 3, node number 4, and node number 5, something like this, and if you try to connect them, how it will look like? It will look something like this, right? If you see the execution, it's something like 1, then 2, then 3, then 4. If I consider that this is true, okay, this 2, then 2 after 2, 3 will come, not 5, then 4. After 4, I will go for 2 again, right? And if it is true, then I will go for 3 again, then 4. Then after 4, I will go to 2 again, and if I still find that this is true, then again 3, then again 4, and then again 2, and then if I say that this is false and this at this point of time, then I will go for 5 and it stops. Now you see a very interesting pattern you can find over here, that is after 1 then 2, you are actually getting a pattern 2 3 4 2 3 4, something like this, until a condition come where it become false. So you can say this is what you are actually having a circle within this particular closed one, and this is what we can call a loop, and that's why the name is loop. Now one thing very important over here, that is in this particular loop, which are the nodes involved in the loop? Node number 2, node number 3, and node number 4. And in among these 3 nodes, node number 2 contain the condition. So condition acts something like a gate. If the condition is true, you can enter in the loop. If the condition is false, then you can exit from the loop. As simple as that. So for time being, if I consider that this condition even false at the first attempt, then you are not able to enter in the loop for the first time also. For example, I is 0, n is 5. 0 is lesser than 5, which is true, that's why you can enter. But for time being, if I say that in I will be not 0, rather suppose if I want to initialize the I, something like, for example, if I say that I is equal to 6, then n equal to 5, just for time being. If I say, is it possible to enter in this printf bit part? No. The reason is that when I is lesser than n, even for once, if it is false, then it will come in the end part, and there is no way to come back in the main part of the loop from the node 5, right? That mean if someone asks you that what is the minimum time you can execute in this form of loop, you must say the minimum time event can be 0, right? Minimum time event can be 0. And one more thing, among this node number 2, 3, 4 which are involved in this loop, which node contain the condition part? Node number 2, which acts like a gate. And among these two, node number 2, 3, 4, which node is basically used first time? First time means which node is basically used first among this node number 2, 3, 4? Obviously node number 2, right? According to the execution, I can see node number 1, then 2, then 3, 4 can. Before executing 2, you cannot go from 1 to 3 directly, right? So that means one thing you can say, that before you enter in the loop, you have to actually, the gate must be opened, right? If the gate is even closed, for example, when I was 6, gate is closed. 6 lesser than 5, false, that means closed. That means you can never enter in the loop, right? But if gate is open, for example, when I is 0, 0 lesser than 5, gate is open, then you can enter. That's why this type of loop is called entry control loop. That means the entry point of the loop is controlled by the condition. Okay. Now I can have a similar situation over here. I can do it in a different way. You see, the same thing I will do in a different way. Let's see. Let's write it first. I can write that, say, int I equal to 0, int n equal to 5, suppose. Now the difference that I will do, before I check it, I will print this. I will first print this. Print bit. And then I will increase the statement. I will increase the variable, the counter variable, which represents how many times I have printed. And then I will put checking that I is lesser than n or not. If I do in this way, that means what basically you are doing? You are actually, this is your oh sorry, this should not be in this way. It should be something like a diamond, and then I'll have a something like this. But after this one, what I will do, if it is yes, true, if the condition is true, then I will re-execute this part, and if it is false, I will come to an end. So if I want to do this, then what basically you are actually doing, if I just do the same thing, this is line number 1, this is line number 2, this is line number 3, this is line number 4, this is line number 5. Okay, and if I just write the situation over here with the nodes, node number 1, then node number 2, then node number 3, then node number 4, and then node number 5, and if I connect them in the same way as I have done in the previous case, either from 4 I can go to 5 or I can go to the second point, right? Now see, if you want to make a assumption of this execution in the same way as I have done, it will be something like how? It will be 1, then 2, then 3, then 4. If this is true, then you are doing 2, 3, again 4, sorry. If the 4 condition is true, then again you are 2, then 3, then again 4, and then if the 4, if I consider the condition is false, then I will go to 5. So here also you are actually getting a same pattern, 1, then 2, 3, 4, 2, 3, 4. But can you tell me what is the difference? Difference is that in previous case the condition was present over here, in the loop the first statement, but here the condition is present over here. You see, right? That means as a last statement of the loop. So here also we have the same type of execution, but since the condition is present at the end, that means one thing I can say, that the node that are involved in the loop, that is 2, 3 and 4, these 3 nodes are involved. This one is not involved in the loop, it's not repeated. 5 is not involved in the loop, only 2, 3, 4 is involved. Among these 2, 3, 4, the first node that we are getting in the loop is 2. Obviously after 1, 2 will come, but 2 does not contain any condition. Since 2 does not contain any condition, that means I can say that node number 3 will obviously execute without any condition for the first time. Then condition will be checked, and if the condition is true, then only it will go for 2, then for 3 and so on. So here you see what actually we are doing. We are keeping the gate. If I consider the same concept of gate just like we have done over here, we can say the gate is present over here, not at the first part of the loop, right? And if the gate is open, then you can re-execute the loop. But if the gate is closed for the first time, then you can come out from the loop. But if I say, you see over here, if I consider that I is 6 instead of 0, if I say that I is equal to 6, then if I ask you that tell me how many times this particular print statement will get execute, you should say that it will execute once. The reason is that this printf statement does not require any condition, because the condition is not before print. Printf statement will execute without any condition, then I will increase, and then it will see that I will increase means I become 7, and it will find 7 less than 5, which is false. That's why it will come into the end. It will not re-execute. That's true. The re-execution will not happen, but once printf already printed, at least once bit has been printed. That means in this type of category or situation, if someone asks you what is the minimum number of execution you have, you must say it is minimum number of execution will be surely 1, not 0. But in this case, if I say instead of 0 it is 6, it's at the very beginning, before print statement the gate will close. and it will come out from the loop and never this print will execute. But it is not true in this way, in this particular case. So what actually you are doing over here, you are allowing your program to print the statement or maybe some another job at least once, and then you are checking whether you will allow the allow the program to print bit second time or not. So we are from the with the concept of loop, what you are saying, you are allowing your program to enter within the loop. Now you are checking at the end whether you will allow to re-execute the loop or you will come out from the loop. So basically what actually you are doing, you are actually checking, you are actually trying to control the exit part of the loop, not the entry part. If you control the entry part, there will be a possibility that this statement 3 will not execute even once, which is not true over here. That means you are allowing without any condition, you are allowing your program to enter in the loop without any condition, but you are controlling the exit with some condition. But here you are allowing your program to enter in the loop. You are not allowing your program in the loop without any condition. That's why this particular type of strategy is called exit control loop. This is what we call exit control loop. Okay. So now that means what actually, as a brief, what I can say, the loop can be of two types. If I say a loop can be of two types. One is called entry controlled and one is called exit controlled. Right? Now what are the different type of loop we have in the C language? For entry controlled category, we have two different loop we can write. One is called for loop and another is called while loop. And for the exit control, the loop that we write is called do while loop. So these are the different loop we will see one by one in through different type of problems.